Alright guys, my name is Harrison and today we're going to be learning about carboxylic acids, how to identify them and how to name them. So you can identify a carboxylic acid by the double bonded O right here and then the OH bonded right here, all at position 1, or they sometimes have two of them at position 1 and at the end of the chain. So your longest carbon chain here is 5. 1, 2, 3, 4, 5, and then you have two ethyls, so at positions 2 and 4. So for that reason it's named 2,4-diethyl pentanoic acid. The ending for the carboxylic acid is oic and then acid added to the end of your longest carbon chain, which is pent, and there's only single bond, so it's an, so it's pentanoic acid. Alright, here's another example of a carboxylic acid. This one has two carboxylics. They have this double bonded O right here, and then an OH and an OH right there. And the longest carbon chain is 4. 1, 2, 3, 4, and then you have two methyls, one right here at positions 2 and 3. So to name this, you're going to start with the methyls. 2,3-dimethyl, bute, because it's 4, and because there's only single bonds, and then dioic because there's two carboxylic acids, and then so it's butan dioic acid. Alright, here's another example of a carboxylic acid that is relatively simple. So you're going to start numbering it. Again, obviously you're 1 right here with your carboxylic acid, 1, 2, 3, 4, 5, and then position 6. So that's your longest carbon chain is 6. And right here you have an extra amino, and then you have a double bond at 3 and a double bond at 1. So to name this, you start 5, because the amino is at position 5, 5 amino, and then hex, because it's 6, dash 1, 3, dianoic, because there's two double bonds, dianoic acid, because it's a carboxylic acid. Alright, here's another example of a carboxylic acid. And right here it's going to start numbering 1, 2, 3, 4, 5, 6, 7. And you have carboxylics at positions 1 and 7, so they're the bookends. Then you have a cyclopropyl at position 4, and then a alkene at position 1. So to name that, you're going to start 4 cyclopropyl, because it's right there. Then hept, because it's a 7. 7 is your longest carbon chain. 1-N, because you have a alkene at position 1. Hept N dioic acid, because there's two carboxylics. Alright, here's a more complex carboxylic. So again, you're going to start at the carboxylic at position 1. So 1, 2, 3, 4, 5, 6, 7, and 8. So that's your longest carbon chain, 8. Right here you have a cyclopentyl and then a cyclopropyl, and then right here you have a methoxy. Then you have two double bonds at positions 2 and 4. So to name that, you're going to start with the cyclopentyl, because that's what name comes first in alphabetical order. So 5 cyclopentyl, and you go to 7 cyclopropyl, dash 4 methoxy, and that takes care of all your groups. Oct, because your longest carbon chain is 8. Dash 2, 4, dash di-N, because you have two alkenes at 2 and 4, and then oic acid, because it's a carboxylic acid. Alright, here is the final example of a carboxylic acid. Here you start numbering here with your carboxylic, which is 1, 2, 3, 4, 5, and 6. And then to name it, you're going to start with 6 right here, cyclopropyl, because you have a cyclopropyl at position 6. Then 3, 4, dioxo, that's what you call the double bonded oxygens, and that positions 3 and 4. And then hex, because your longest carbon chain is 6. Dash 2, 4, di-N, because there's two aldehydes at positions 2 and 4. And then oic acid, because it is a carboxylic acid. And that is it for carboxylic acids.